Hey guys, my name's John. I'm here to talk about assignment number 3 for the EEC1103.
Hi there, using the arrow keys on your device, help Kitty Cat navigate the maze and find the red milk located at the top. You can partner with a friend and together practice the directions of up, down, left and right.
So I reverse engineered this activity, having already taught early primary school in 2020, both face-to-face and remote, teaching numeracy. I've coded the cat sprite size to make it not too easy to get through the maze. I've also given him an upright standing position with some movement animation.
Well done and congratulations, you have successfully navigated the maze and located the red milk carton. Woohoo! If you want to play and practice again, please click the green flag.
Linking the activity to the Victorian curriculum. The curriculum is a common set of knowledge and skills required by students for lifelong learning, social development and active and informed citizenship. The curriculum area is mathematics, with the strand being measurement and geography. Substrand using units of measurement, location and transformation, and the content description. Describe position and movement, you can see the code there, and the elaboration, following and giving simple directions to guide a friend around an obstacle path. The audience and year level is foundation level and is designed as a warm-up activity for a numeracy or math session. At the end of this activity, users should be able to describe position and movement in their immediate environment, and the skills knowledge gained, practiced or developed should be everyday positional and locational vocabulary. The letters SAMR stand for substitution, augmentation, modification and redefinition. In augmentation specifically, the technology is directly substituted for a traditional tool or method, but with significant enhancements to the student experience. The key question here is, will the technology increase or augment a student's productivity and potential in some way? Bloom's taxonomy is a framework which categorizes levels of cognitive process or thinking. My students are using their higher order thinking of the apply category within the scratch activity, because working in pairs, which is optional, students solve the directional challenge operating arrows on their device to move the cat sprite, and in doing so need to evaluate, there's a verb, and communicate, which is the best travel or positional direction. My activity incorporates the active critical learning principle. They have to use their higher order thinking and communication skills to navigate directions which they have agency over through the keys they use. Also the practice principle, it's designed to be challenging but doable, and there's a encouraging voiceover at the end to encourage them to start and practice again, so more time on task. And the multimodal principle, my activity incorporates voiceover prompts, music and basic movement animation. Okay, so looking at learners with disability, according to Deakin University, autism is a condition which impacts the way students may experience and interact with their environment and others. And how I can support my autistic student is that I actually will take a strengths-based approach. Autistic children may naturally have good visual perception skills and visual recognition. So in this instance, using a maze and being able to effectively recognize patterns and solve problems would act as a confidence building exercise for that participant. My activity has recursive feedback because the participant gets straight up audio feedback once they successfully complete the task. There is also collaborative intelligence. There's a front-end voice prompt to get them up and running with some instructions, and that also caters for differentiated learning insofar as it does cater to learners with disabilities such as autism. So firstly, I got on Scratch and looked around at other projects, playing around with coding blocks. I was overwhelmed as all get out with no comprehension of coding language or format, and was stuck on how to move forward. Then I searched YouTube videos and found basic step-by-step instructional videos which I followed as a template. This facilitated me hands-on learning the language and noticing patterns within coding. That was the building block, literally and metaphorically. The YouTube version I learned from had limitations, but now with base knowledge, I spent several hours of trial and error coding enhancements to my activity, such as voiceover, music, even sprite movement animation. I'd certainly go straight to a YouTube instructional video for my next coding activity. One aspect for future coding to be mindful of is the language and vocabulary featured in the activity for my target audience and age group. In fact, my daughter asked me what navigation means. So through coding as a vehicle, I went through problem-solving process of starting out with the end in mind, seeking, finding help and information on the internet, implementing an action plan, even through the pain points and getting the solution. These are all 21st century learning skills. Coding requires children and learners to draw upon and develop these 21st century skills, with the so-called soft skills, but also the mechanism and structure of coding has carryover in all other curriculum areas. It's these distinctions that learned by this activity that I'd use in an education setting within the premise and framework that creating content, not passively consuming content, enables us to add value to broader society.